welcome to a little video about the Unit 7 test review. Let's get started. For number 1, I'd like us to write an exponential equation for each of the following functions, tables, or graphs. So, our exponential function looks like this. F of x equals a times b to the x. A is our y-intercept and b is our pattern. Let's check it out. In number 1a, our y-intercept is 84. This is our A. Now, let's find our pattern by doing y2 divided by y1. Let's make this y1 and this y2. B equals 84 divided by 504. 84 divided by 504 is 16. So, f of x equals 84, because that's an a term, times 16 to the power of x. Fantastic. Onwards we go to letter B. In letter B, I give you 4 points you can use, but we really only need 2. Let's label them. The first thing that I always like to label is the y-intercept. The y-intercept here is 0, 8. That's our A. The other point that I have that I can use, what do I feel like using? Let's do this one. 1, comma, 4. I'm going to create a tiny little xy table and make sure I'm putting my numbers in order for x's, so means smallest to largest. That means 0 and then 1. So 0, 8, and 4. I'm going to label this as y1 and this as y2. So in order to find b, I'm going to do 4 divided by 8, which gives me 1/2. So the function for this graph is f of x equals 8, because that was our y-intercept, times 1/2, because that was our pattern, to the power of x. Let's do one more. Here we go. There's our A, it's 3. And then I'm going to label this is y1 and this is y2. Let's find B by doing y2, so 75 divided by y1, which is 15. 75 divided by 15 is 5. Alright, let's write our function. F of x equals 3, parentheses, the 5 that we got from our pattern, to the power of x. Fantastic. Not too bad, right? Next, let's complete the table and graph for the following functions. Now, if you're watching this video, you should be using your calculator along with me. And I know some of you are listening to this with no sound, so I'm going to write it. Practice using your calculator. In case that's for the people who are not listening to the video and just watching it. Practice that calculator. It cannot help you during the test. Right. Here we go. Just as a reminder, the way we get an exponent is by pressing this little caret button on our calculator. So, let's fill in the table. I'm going to use the function that I'm given, and I'm going to replace x every time. So I got 2 times 1/4 to the power of -3. Again, practice putting this into your calculator. You should get 128. If you don't, you did something wrong, and you should call me over now, because I cannot help you during the test. Next, I'm going to raise it to the power of -2. I recommend, if you're watching this, to pause the video, enter this into your calculators, and then check my answers. 2. 1, 8. 0 gives me 2, and then 1 gives me an answer of 1/2. Now, looking at my graph, it only goes up to like 30 something, so I am just going to graph these points. I don't know about the 1/2. I'm going to graph all the whole numbers. Okay, let's do it. -2, 32. That's the first point. Again, I'm going to expect you to be able to graph on your own, so practice graphing. -2, 32 is right here. Whoa. It's right here. Oh, that's right here. Next, I have -1/8. And then 0, 2. Here's my line. Let's try that one more time. Again, practice that calculator. Practice graphing. Same as before. Just like before, I hope you put this into your calculators on your own and practiced it. I know I'm repeating myself, but once again, I will not help you. I'm not allowed to help you put this into your calculator. I'm going to graph all these whole numbers. So I'm going to graph 0, 3, 1, 12, and 2, 48. So if you finish this so fast that I know you're just copying down what I wrote, I'm going to send you back to practice it in the calculator. Just like me. And I'll say that out loud during class as well. Let's graph 0, 3. I'm going to zoom in here. 1, 2, 3. And 1, 12. And 2, 48. There's 2. There's 2. These are graphs. If you need help graphing, you gotta let me know today. Otherwise, you will not be able to graph during the test. In number 4, what I'd like us to do is to take this function and move it 3 units up and 2 to the right. To the right, and up. Right. Slope always goes up and then to the right, so let's do it. 3 up. 1, 2, 3. 2 to the right. 1, 2. There's my new point. Up 3. Right 2. Up 3. Remember, if we're flattening out at 0 and we're moving up 3 spots, you want to make sure you're flattening out at 3. Our asymptotes move up and down with our function. Number 5 is similar to 4, except instead of drawing and moving the line, I want you to tell me what happened with the line. Now on your paper, it's black and gray, but I labeled the functions with f of x and g of x. So the graph of f of x and g of x are shown below. F of x is 4 to the power of x, so write the function g of x. What this tells me is we go from f to g. So the movement goes like this. I'm moving down. Okay, that's good to know. How many am I moving down? Well, let's count. I'm moving down 1, 2, 3, 4, 5, 6, 7. I'm moving down 7 spots. Down is subtracting, so g of x is going to be 4 to the power of x, which was the original function, and then minus 7 on the outside. For number 6, what I'd like us to do is to write the equation of the function after translating it as described. For g of x, I'm going to start with 7/5 to the power of x, just like the original, and then I'm going to translate it 100 to the right. Translating to the right is inside the exponent, and it's subtracting. That's it. Letter B asks us to translate that function 13 units up. I'm going to start h of x the same way, 5 times 15 to the power of x. 13 up is a plus 13 on the side. For letter C, I'm going to start j of x the same way it's written, 1/4 times 7 to the power of x. To move it 70 units to the left, we're going to add 70 in the exponent. And to move it 4,000 units down, we're going to subtract 4,000 on the outside of our function. Number 7 asks us how we can tell if a function represents growth or decay. Write an example of exponential growth function and a decay function. Right. You look at the parentheses. If the number is greater than 1, it's growth. Here's an example. F of x equals 3 times 1 plus 0.5 to the x. If the number is less than 1, oh, I forgot to say, or addition, or plus 1, so, or subtraction, it's decay. So I'm not reinventing the wheel, I'm just writing a minus to the same function included. Okay, beautiful. If you have questions about that handwriting, you let me know. Okay, number 8. Bridge City has a population of 15,000 people. Its population is decreasing at a rate of 1.5% each year. Let's determine the population of Bridge City in 10 years. Okay, this is how we're going to write the function. F of x equals. We start it with the amount of people, so 15,000. Then we have a parenthesis and a 1. Then we decide if we have a plus or a minus in our function. Here, we're going to have a minus. We're going to have a minus because it's decreasing. And it's decreasing at a rate of 1.5% a year. In order to turn our percent into a decimal, we have to do 1.5 divided by 100. We get 0.015. I'm looking for the population in 10 years. So I'm going to put a 10 up here and in here. And what we're going to do is we're going to take this whole part and put it into your calculator. What do you get when you do that? So practice, practice, practice. Now remember, we have people here. You cannot have point something of a person. So I'm going to round it to 12,895. Number 9. Cisco deposits $500 into a compound interest account. The interest rate for this account is 3.25%. Let's write a function that represents the balance as a function of time and determine its value after 5 years. 15 years. Now, we start our function the same way with an f. We're plugging in 15, so let's put a 15 instead of x. It starts with 500 because that's what we're putting in. And the parentheses and the 1. We have to determine whether or not we have a plus or a minus. We are depositing. That's putting in, so we're going to have a plus. And then 3.25% as a decimal is 0.0325. And we'll give it a power of 15 because that's what we're evaluating. This whole thing goes into your calculator. Please take a chance to practice. And let's see how much money we've got in there. Your answer should be $807.83. Beautiful. Last one. In number 10, we are going to be using this graph to answer some questions. You bought a car for $40,000 in 2018. That was a nice car in 2018. Now those are more like, I don't know, 70,000, let's say. Yeah. The value of the car decreases by 11% each year. Here is the graph to show. A. Estimate the year that the value of the car will be half of what you spent. Well, what is half of 40,000? To find that, I divide 40,000 by 2, and I get 20,000. All right. Well, 20,000 is right here, which means it hits the graph there. Let's see what year that is. Oh, that looks like year 6. But 6 isn't a year. It's years since 2018. So what you have to do is 2018 plus 6. So the car will be at $20,000 in 2024. Let's see the year where it will be 26,000. 26,000, looks like it's going by 2,000s. So 26 on the sheet. 4. 4 isn't a year. We have to find out what actual year it is by doing 2018 plus 4. Now we get 2022. Lastly, let's estimate the year where the car will be at a value of $8,000. 8,000 is right here. Oh, looks like it's year 14. Let's find out what actual year that is, because 14 is, it was a year, but none of us were alive back then. It would be the year 2032. If you have any questions about what you've seen, please let me know, or whoever else is helping me out with math know. Otherwise, have a wonderful, wonderful rest of whatever day it is for you.